Possible solutions for restricted domain C3. Find all possible values of angle theta rounded to one decimal place for tan theta equals to minus 2.3456, where theta is between 0 and 360 degrees. So as we have seen in earlier videos, we can find the angle of theta by taking tan inverse of the value given. Now we'll follow the two steps. First is, since we know that tan theta equals to minus 2.3456, negative here indicates that the angle theta should lie in which quadrant? Negative value of theta means that the terminal arm should be either in quadrant 2 or in quadrant 4. This we get from the cast rule, right? So the cast rule says that tan is positive in these two places, so it is negative in either quadrant 2 or in quadrant 4, right? So we are looking for two solutions here. So let me just draw randomly a line showing the two possible solutions, right? So we still don't know what this angle theta is or what this angle theta is. So these are the two values of theta which will result into solution, right? So we have to find these two values of theta, right? So from negative value we find that our solution should be in quadrant 2 or in quadrant 4, right? They are 180 degrees apart. Tan theta has a time period of 180 degrees, right? Now to find the value of theta, what we can do is, first let's find the related acute angle. So first step is to find the quadrants. Second is find related acute angle, which you can find by, let's say related acute angle is alpha. We are saying this angle alpha, right? So we are just finding the angle alpha for this value of minus 2.3456. Let us assume that we are only finding alpha will treat as a positive angle. So what we can do here is we can find alpha as tan inverse of the value, which is 2.3456, right? So let us find the acute angle first. So we'll do tan inverse of 2.3456. That gives us 66.91. So we get 66.91 degrees. Rounded to one decimal place, we get 66.9 degrees, correct? So we know this angle is alpha, which is equal to 66.9. So the second step here is find the related acute angle. Whenever you find related acute angle, you just use a positive value, right? So between 0 to 90 degrees, you know, all trigonometric ratios are positive. That is the reason. So we know that our solution is in quadrant 2 and 4. Alpha could be this or this, right? So this acute angle is 66.9 degrees for us. That is the acute angle. Now, what is the angle? What is the principal angle theta? Whenever we are saying angle theta, it really means from x, positive axis, counterclockwise. So the first solution for theta is 180 degrees minus alpha, which is 66.9, right? And the second solution of theta will be this angle, which is 360 degrees minus 66.9, correct? We can always use calculator and calculate this value. 180 take away 66.9, and that gives you 113.1. And the other one is 360 minus 66.9, and that is equal to 293.1. You can always check your answer. These will be 180 degrees apart. So if you find the difference between them, it should be 180 degrees, right? So we get two solutions to this problem. We say answer is theta equals to 113.1 degree or 293.1 degree. Okay. Now to summarize, when we are trying to find the angle theta for the given trigonometric ratio, first step is from the sign figure out the quadrant we are interested in. Since tan is negative, quadrants are quadrant 2 and 4. Second step is find related acute angle. To find related acute angle, find tan inverse of the value. Do not consider the sign. Just take a positive value. Acute angle means less than 90, and in the first quadrant all are positive. So we did tan inverse of 2.3456 and we got it as 66.91. Acute angle is the angle which terminal arm makes with the horizontal line. So we got two acute angles here, right? For two different positions. Now the answer for theta is always the principal angle which we should give as the answer from positive x-axis to the terminal arm. So in the first case it is 180 minus alpha, the second case is 360 minus alpha. So that is how you get the possible solutions. I hope the steps are clear. Thank you and all the best.